Hi all, this is Hani. Welcome back to YouTube channel Code with Hani. Today we are going to solve July day 26 LeetCode challenge, which is maximize subarrays after removing one conflicting path. So what the question states says we'll be giving an n which represents an array nums containing the numbers from 1 to n in order. Okay. So additionally they will be giving us a 2D array conflicting pairs where the conflicting pairs of high content to A and B indicates that A and B form a conflicting pair. So remove exactly one element from the conflicting pairs. Afterwards, count the number of non-empty subarrays of nums which do not contain both A and B for any remaining conflicting pair. So once we remove whatever the maximum number of subarrays possible after removing exactly one conflicting pair, we should remove. So here let's take a look at this example. N equals to 4. So here the conflicting pairs they have given us 2 3 and 1 4. So initially we are removing 2 3 conflicting pairs. Now we have removed 2 3. So the subarray may contain 2 3 both together. So now the conflicting pairs is 1 and 4. So there are 9 subarrays in nums where 1 and 4 do not appear together. So generally 4 will have a maximum 10 subarrays. In that where 1 and 4 appears, that subarrays you should not taken into a count. Okay, after if you see here 1 2 3 4 1 5, so 1 2 2 3 3 4 1 2 3 and 2 3 4, we don't see 1 1 4 together, right? So yeah, so now the maximum number of subarrays we can achieve after removing one element from conflicting pairs is 9. So if you would have removed instead of 2 and 3, we could have also need to see 1 and by removing 1 and 4 how many pairs are formed. So then here among if you remove 1 and 4, we got 9 subarrays. If you would have you should remove 2 and 3 means you should have removed 1 2 3 pairs, right? So which means 10 minus 3 will be 7, which is less compared to removing 2 and 3. If you remove 1 and 4, our subarrays are 7. If you remove 2 and 3, our subarray count is 9. So what we have to do, we have to return the maximum. So like this, we'll be counting all which is giving us the maximum number of subarrays possible after removing exactly one conflicting pair. Okay. Next, if you see n equals to 5 here, and the conflicting pairs they have given is 1 2 2 5 3 5. So here what they are telling, remove 1 2 from the conflicting pairs. Now the conflicting pairs will become 2 5 and 3 5. Now there are 12 subarrays and nums where 2 and 5 do not appear together. So 5 means which is 15. Okay, so the maximum number of subarrays we can achieve after removing one element from the conflicting pairs is 12. So yeah, now let's take a look at the visual representation how we are going to approach this. So this is the example I'm going to take. So n equals to 5 and conflicting pairs equals to 1 2 1 5 1 3 5. So what the question states, we should not include these pairs of subarrays together. For example, if it is 1 2, 1 2 should not appear together at all. Okay, if it is 1 5, 1 5 should not be appear together. If it is 3 5, 3 and 5 should not appear together. So we have to remove all these pairs. Okay, if you remove all these pairs, let's see how many subarrays were there. 15. If you remove all these conflicting pairs, what are subarrays? 1 2 3 5 you should not have, 1 2, and you should not have 1 5, you should not have 3 and 5 together. So we have removed six subarrays. So only already 9 valid subarrays were there. Okay, now with this 9, if you are removing 1 and 2 from the conflicting pair, we will be, what is our answer? 1 and 2, if you remove, you can have 1 and 2 together. So only 1, these are the invalid subarrays. So these 3 subarrays can get added. So 9 plus 3, if you are removing 1 and 2 from the conflicting pair, we will be getting 9 plus 3, which is 15, right? But if you are removing 1 and 5, we'll be removing only one. We can have this one as a valid, all this still not valid, so we'll be getting 9 plus 1, which is 10, if we are removing 1 and 5 from our conflicting pairs. So if we are removing 3 and 5, will be these two become valid, right? 3 and 5 form a valid subarray. So then 3 and 5 will be have 9 plus 2, which is 11. So among this, which gives us the most maximum number of subarrays, which is 1 and 2. By removing 1 and 2 from the conflicting pairs, we are having more subarrays, right? So that's what. How see the minimum for the same, if you are for the 1, these are the starting index. Okay, we will have a 2 array, b min a, b min 1 and b min 2. Let me explain how b min, why b min 1 and b min 2 works. Here also, if you see, whatever the nearer, for example, the same starting index, this is the nearest and this is the farthest point, right? Nearest to j, this is farthest to j. So if you see among these two, what which is near give us the, if you remove that conflicting pair, that is maximize our number of subarrays, right? The reason behind this, it is a subarray. Okay, so to form, if it is something farthest point, for example, 1 comma, let's assume 1 comma 5. Okay, so to form the two, if you should not have these 2 points, okay, you need to traverse 4 subarrays and you have to go here. But if it is 1 2, to form all the, if it is near, this will the nearest point will be present in other subarrays which is starting at 5. So if you remove the conflicts from the nearest, it will increase your maximum number of subarrays than farthest point if you remove. So that's why we have a b min and b min 2. I will explain why we need b min 2 later, because you have, if you are removing one conflict, okay, the for the same point the next conflict is at 5, right? So to the max we can remove one conflict, right? So to the same point we will have the next conflict at some point. So that's why we are storing the min and second minimum. If after, if it is to, if the same index has some other conflict in the given n, so we will be storing that next conflict to count the number of valid subarrays. Okay, so why we are choosing the minimum, I have explained, to maximize the valid subarrays. If it is minimum, we will need, we are see 1 2 3, these are next to each other. So to form the valid subarrays till the end, if it is nearer, it has to present in all the subarrays, right? So that's why we are removing the nearest conflict and we are storing whatever the nearest min. Okay, so that's how we would have stored. So if you have see here, I am storing 1, this is the b min 1. 2, the same for the second conflict comes for the same 1, so I am storing it in a p2. For 3 we have only 1, we are storing it at 5. So if you have same 1 comma 6, okay, we don't need that 1 comma 6 anyway, because we are going to remove only one conflict. Okay, and the next conflict present at 5, even whatever the thing exists after that, that is should cross 5. Okay, even if you have 1 comma 6, let's assume as a point, first we'll 1 to the max we can remove only one conflict. If you have removed 1, the next point is 5. Okay, at fifth index itself we are getting a conflict. So to form from 1 to after fifth any point, that should cross as 5 5 6 7 5 6. So if 5 itself not valid, how come 6? So there is no point of storing it anywhere, and that taken into account of valid subarrays. Okay, I hope this makes sense why we are storing the min, b min, b min 2. This is a first smallest conflict. So I have explained why we need second, so that if you are removing this conflict to the max, we can go our next conflict is 5 till the 5 only, till 4 only you have valid, 1 and 5 should not be present, so that's why we need the second smallest to conflict as well. Hopefully this makes sense why we are doing this. Till now we have stored beam in 1 and beam in 2, right? So that will give us first smallest conflict and second smallest conflict of any particular index. I even explained why we need not to store further conflict, because to the max we can remove only one conflict. If the second conflict exists, okay, to the max we can going to remove one. Already we have removed one conflict. This for sure will present in any of the subarrays that is going to create it further, so which will not taken into a valid account. Okay, that's it. So these are the cases. If you remove 1 comma 2, will be getting 9 plus 3 12. So this is 1 comma 5. If you are removing 1 comma 5 and 3 comma 5, what is our total maximum number of valid subarrays we will be getting? So here if you see, if you need to remove 1 comma 2 or 1 comma 5, you should remove 1 comma 2 to get the maximum, because that is the nearest to the 1 starting point. So if it is nearer, that will be included in all the subarrays which is not valid at all, right? Yeah, so if you're removing nearest conflict, you will have more number of valid subarrays. Hopefully this makes sense. Now let's see how we are going to calculate. Now we know the total number of subarrays. Now we'll be calculating what are the subarrays that doesn't have a conflict. So now we should calculate the result 9, right? So then if you are removing this conflict, what is our result? If you are removing this conflict, what is your result? If you are removing this conflict, what is the result? So we will be storing this in a delete count. Okay, 3 1 2. Okay, so with this valid, what is the maximum of this 3 will take, that we will be returning into a result. Now just take a look at how that works. Okay, okay, this is the solution that we are going to use to solve this approach. Maybe let's run through the example so that we'll have a better idea than why we are using this or that conditions. So initially, as we explained, why we need b1 and b min 1 b min 2 arrays we need is because to store the what is the conflicting index, which conflicting index we have to going to remove. We have to going to remove the nearest conflict index, that is at b1. The next conflict index is at b2 to get the if you are removing 1 2 for example, to the next conflicting index is at 5th position. So we know, okay, that till that only we have the valid subarrays that starts with for 1. To get that, we are storing the second conflicting index for the same. If not, we will not store the second conflict index. We'll have the maximum value, which is they have given 2 to the power of n, could be the conflicting pass length. So we have just taken 2 to the power of 31, so that could be the maximum, right? Okay, I hope this is how that we are storing it. A b will be taken each pair into an account if b of min a is greater than b, which is, so b1 for example, initially pair counting pairs, what will be, it will go 1 comma 2, right? So a will be 1 and b will be 2. So it's not always will be having 1 comma 2, there can be 2 comma 1 as well. So yeah, we will be taking always which is smaller as a and greater as a b. So b initially what will be our b min of a, which is 2 to the power of 31, that is greater than 2, right? So what we will be doing, we will be swapping the to power the 31 to b min of 2, and we'll be updating the b min of a as Okay, but in y, which means whatever the current b min of a will be the minimum. Okay, if another minimum comes which is lesser than the current minimum, the current minimum will be the second minimum, right? So that's why we'll be updating b min of a equals to b min 2 of a with whatever the value that has b min of a. For example, if by any chance if uh, we would have received 1 comma 5 first, then 1 comma 2. Okay, in that case first we would have updated first b min of 1 to 5, and this would have been 2 power of 31. So next when 1 comma 2 comes, okay, now 2 uh, now 5 is greater than 2. Okay, 5 is greater than 2, then b min 2 of a will swapped with 5 and b min 1 will be having the value 2. So always b min 1 of a will have the smallest and b min 2 will have the second smallest. Okay, like that we will be updating, and our b min of a and b min 2 will be having values like this. If you are traversing from here to here, it's very hard to figure it out what is the next bmin, or tell what our path should go for. And for example, for this, if you are taking this is our current index. Okay, having 1 2 3 4 and 1 2 3 1 2, so and so on. So if but if you see our first conflicting path is at 2, so tell only one resultant array that it can form us, which is only one, nothing else. So what we are our current result will be doing, so it will calculate from this is the jth position. So this one can have subarrays till 1 1 2 1 2 3 1 2 3 4 1 2 3 4 5. These are the subarrays that it can form, but the conflicting path is present at 2. So if our I is at position 1, the jth conflicting path is at 2. So if you minus this, what we will be getting? We will be getting current conflicting index. Okay, b min of I will give us our current conflicting index. So now you can take only this I minus j, which will give us only one pair that is valid. That will be adding it to our total. This delete count, what it will happen keep is, now I'm going to remove this conflicting pair 1 comma 2 from my result. Then what does my next valid index next conflicting index is 5, right? Till then I can use all the values, right? So till 1 2 3 4, which just give us currently 3. So my delete count will have till next conflicting index how many pairs that I can add more. Okay, so our current conflicting pair is at 2. Okay, so it will count next conflicting pair is at 5. Okay, now till 2 if 2 wasn't conflicting pair, so 5 minus 2. So basically what it will do is it will the delete count will count the number of remaining valid subarray. Our next conflict is 5. So if the next conflict is 5 1, this is 5, right? For 1 you would have already added a resultant. So 5 minus 5 is the starting conflict. So 4 minus 1 is 3. That will be added to our delete count at 1. So for this one I can have 3 more. if I'm deleting 1 comma 2. If I'm deleting, next 3 comma 5, we won't delete 1 comma 5 because like that only we will store it, because we know if the same index is starting with a different conflict index, whatever is minimum that we will be taking. So if you are deleting 3 comma 5, okay, I don't have any conflict. If I'm deleting 3 comma 5 until nowhere, I don't have any conflict. So till the end, it would have counted 3 3 4 already, which will give us 2 as a result from traversing back from here. How many subarrays that you can form? It would have resulted in 3 and 3 4, which is already the resultant is 2. Now from 3 to 5, if the 5 is not conflicting index, you will have one more, right? 3 4 5. So the next is n plus 1 will be our answer. Current conflicting index is 5. 6 minus 5, how many subarrays I can form? 1. So that it will add at 1. So among this, now we have figured out what all the if I deleting 1 2, what is my maximum subarrays? I'm getting 3 3 1, what is my maximum subarrays? If I'm deleting 3 5, I'm getting maximum valid subarrays as 1. Among this, which is maximum? 3. So our resultant will be 9 plus 3, which gives us 12. So this is how it works. Okay, now I just explained visually. Now I'll just go through the code. Now initially our result is 0. This is, as I mentioned, IB1 is current conflicting index. First, initially our current conflicting will be is none, n plus 1. Let's assume it is 5. Okay, now my delete count, I am having it as a array. Initially I starts at 5, it will go till 0. My b min of IB1 is n. What is that? It is 2 to the power of 31. Is greater than 2 to the power of 31. It's both have 2 to the power of 31. So what it B2 will store? B2 will store the B2 is nothing but next conflicting index. Okay. So the next conflicting index is still the 2 to the power of 31. Now the B2 will be updating to 2 to the power of 31. This will be 10 to the power of 10 initially. Now it got updated to 2 to the power of 31. So next our resultant will be, so I am going to start here. From here to here, our subarrays we are going to calculate every time. Generally at any particular index, if for example if our answer is still 7, if our n is 7, our index is at 5. So 5 6 7, how much it can form? 5 5 6 5 6 7. These are the 3 subarrays that it can form, which includes 5. So basically what we will do is, we will be like n minus I plus 1. So 7 minus 5 plus 1 will give you 3. That is the formula that we are using to add the subarrays here. So here b min of IB1, why we are taking? That is the next conflicting index. Till that point only we can take. Conflicting index is nothing but, if I am taking 3 is my I, the next conflicting index is 5, I can't take 3 4 5. So that's what b min of IB1 will give us currently 2 to the power of 31, because for this 5 we don't have any conflicting index. So 2 to the power of 31 is some maximum value that we have taken. So that's why we are taking min of 2 to the power of 1 or 6. So for this 5 we don't have any conflicting index. Minus I is 5. So 6 minus 5, for currently my result is 1. Because only for 5 we can take a subarray of 5 only. Okay, now result is 5 and delete count of IBL. There is no conflicting index at all. Okay, B2 is nothing but 2 to the power of 31 now. 2 to the here 2 to the power of 31 comma this is also to the power of 31. So 2 to the power of 31, 2 to the power of 31 is nothing but 2 to the power of 31 comma 6. So 6 minus b min 1 of IBL also 2 to the power of 31 comma 6. So 6 minus 6 will give us 0. So there is no delete count of IBL because there is no conflicting index at all. Okay. I hope now first traversal you guys would have understood. Now the second I equals to 4. For 4 also we don't have any conflicting index next. So basically what it will do, it just count the subarray. Subarray, how it will count 4 comma 5. So this is the same. Next conflicting index will not add, B2 also will not get updated. Our result only will be like 6 minus 4. I is 4. N plus b min of IB1 is 2 to the power of 31. 2 to the power of 31 comma 6 will give us 6 minus 4 is 2. So it can form 4 and 4 5 as a subarray. Hope now our result will be getting updated to 3. 2 plus 1 is 3. Okay. Now the delete count of IBL. Delete count of IBL is our IBL is still the conflicting index is 5 only. Okay. Our conflicting index didn't get changed because b min of IB1 is 2 power of 31 is still greater than 2 power of 31. So it will not getting updated. So our conflicting index still was 5. 5 again 6 minus 6 will give us same 0. So there is no change in our delete. Next I will go for 3. Now we have a conflict is at 5. So b min of IB1 is 2 to the power of 31 which is greater than b min of I which is 5. B min 1 of I. So 2 to the power of 31 is greater than 5. Now our current conflicting index will get updated to 5. Right? So our B2 will be next conflicting index. Min of B2 also will get our current IB1 is nothing but the next conflict. Now we are going to update IB1 to the current conflicting index. So we are going to give our B2 the previous conflicting index to have the next conflicting index. Okay. Now B2 still IB1 and B2 are same, which is nothing but 2 to the power of 31 you are giving as a B min value. It will hold next conflicting index basically. So IB1 is now getting updated to 3. Okay. Now our result will be getting updated to, now if you see 3 can go till where B min of IB1 which is 5, right? That will be our last index. So 5 minus 3 which gives us 2. So 3, 3, 4 are the valid index that it can form. Okay. So now our result will be getting updated to 2. Now you understand with conflicting index whatever the values that is valid that will get updated to the result. And delete count will be having, if I'm removing this conflicting index, what will be how many subarrays that I can extra add to the maximum subarrays. Okay. Okay. Now our delete count is IB1 was 3. It will get updated to 3. It is 3. B min of IB1 is that we have added. So B2 is nothing but 2 to the power of 31 comma b min 2 of IB1 also 2 to the power of 31. Still our last index was 6. Okay, delete count of so 6 minus, so there was no further conflicting index after 5, so that's why we are taking to the maximum of 6. If there was any other further conflicting index we would have taken that. Okay, for example if 1 comma 6 or some other conflicting index, if you have further arrays, if it has conflicting index till here, if you are removing this conflicting index you can go till here, not till the end of the array. Now if you are removing 3 comma 5 there is no further conflicting index, so we are taking n comma 1. Okay, n plus 1 is nothing but 6. 6 minus b min 1 Now bmin of ib1 is nothing but 5, right? ib1 got updated to 3, which is 5. Okay, bmin of ib1, bmin2 of y, we are taking bmin2 of ib1. That will you will come to know when we are traversing 1 to 1 5. Okay, so now it is 5, comma. If it is there was no conflicting index, you can take the last index. Now 6 minus 5, which is 1. So now basically what we have ignored while we are adding to the result, we have ignored this 6 comma the 5, right? 5 tells whatever the next conflicting index will be our resultant array. Now this 1 would have added, so 3 3 4 we have already added to the result, that is a valid. Now 3 4 5 also would have added, that is the valid answer. So that now our, if you are removing 3 comma 5, now our valid will be 1. Okay, now hopefully this makes sense. Now our I would have gone to 2. 2 doesn't have any conflicting index, but bmin of ib1 is 2 to the power of bmin1 of ib1 is 5, which is greater than 2 to the power of 31. No. So what it will basically do, it will just update our b2 with bmin1 of I. bmin1 of I is nothing but 2 to the power of 31. I'll treat as 2 to the power of 31. It also won't have any, b2 is not getting updated again. So now our result 2 can be at any index, right? It can be present in 2, 2, 3, 2. Min 1 of ib1 is 5, comma 6 minus I. So what is the conflicting, ib1 is having, this is the conflicting index, so you can't have 3 and 5 together, right? So if you take, why we are going for the next, why we are traversing till the next conflicting index is, generally what is our resultant subarray, 2 power 2 3 4 2 3 4 5, we know that 3 and 5 conflicting pair exist. Okay, that you should not add it to the resultant array. That's why we are going, either way we have any conflicting index, the next current conflicting index is at 3. Okay, that is 5. Okay, 5 or 6, which is minimum? 5. So 2 can go form till 5, not, it can form anything before 5, not including 5. So rj is 5. So 5 minus 2, which gives us, and form only 3 valid pairs. So already 3 plus 3 gives us, so 5 plus 3 gives us 8. Okay, our delete count of IBL is 3. So B2, Bmin2 of IBL, anything got changed? No. IBL is still at the same position, so delete count to nothing will be improved. So now our I goes to 1. So Bmin of IB1 is 5, which is greater than 2, obviously. So our current IBL will get updated to B2 will get updated to 5. So second next conflicting index got updated to 5. Okay, got it. So now result will be, so 1 can form till where? 5. That's what. So B min of IBL will goes to 2. So now if you include this conflicting pair, what now IBL got updated to 2, right? So our current, so 2 comma 6, which is maximum, it's a minimum 2 only, right? So 2 minus 1, now it can form only one valid pair, so which is nothing but 1. Got it? So now what it will, result will get updated to 9. Now if you are deleting this pair, okay, our B2 got updated to 5, right? If you are deleting this, till 5 only we can, till before 5 only you can form a valid pair, even if you are deleting one conflicting pair. That's why we are maintaining B2 next conflicting index continuously. Okay, now if you see our B2 is 5, B2 min of IB1 is 5, which is minimum 5 only. Okay, maybe if this conflicting index was 4, let's assume. Okay, but that was a case there you should not form 3 4 itself together. So if you ignore the B2, 3 4 will with 1 3 4 might form, right? So that's why we are forming next conflicting, we are having current conflicting index as well as the next conflicting index to form appropriate delete count. B2 also 5, maybe min 2 of IB1 is also 5 and 6. So among this, what is our 5 minus B min 1 of IB1 is 2. So we have calculated already from 1 to 2. Now we have to calculate from 2 to, which is 5, right? So 2, 3, 4. How many subarrays it can form? It can form 1, 2, 2, 1, 2, 3, 1, 2, 3, 4, which is 3. By subtracting that, we will be getting as the delete count for IB1, which is now is 3. So now we have found our current valid result 9 as well as the delete count of nearest value. Why we are choosing nearest, I have explained clearly before. So by choosing one pair, okay, we will get to know what can it give the maximum. So among this, we have to choose which we are choosing, this or this. 3. So 9 plus 3 is our answer, which is 12. So here 12 is our answer. So time complexity will be order of n, 2n basically, but yeah, fine, technically it is order of n only. So space complexity is just we are storing 2 order of 2n, that is also order of n. Yeah, I hope this makes sense. Let me know in the comments that if you guys didn't understood that something that I could have explained better. I'll be happy to help. So I'll be providing the solution in different languages in GitHub. Please do check it out if you have any queries. So yeah, I hope you guys would have understood and you'll try to solve these questions. So let's have a streak together. Yeah, if you do like my video, please do like, share and subscribe. That will keep me motivated to do more videos daily. Yeah, thanks for watching.